Yeah. Good evening, children. Good evening, online students.
Good evening.
Yeah. Good evening, Aniruddhan, Kamalika, Aragamai, Lassi, and Niveda. Yeah, I've shared my screen. Online children, is it visible?
It's not.
Yeah. Continuing with trigonometry. So let's recall some important algebraic identities, which we will be using to prove the trigonometric identities we want to take up today. Okay. So this is very familiar. This one is also very familiar. Also this one, a square minus b square is a plus b into a minus b. Now from this one, see, just write it like a square plus 2ab plus b squared is equal to a plus b the whole square, right? A square plus 2ab plus b square is equal to a plus b the whole square. Now take this term to the other side. So what do you get? A square plus b square is equal to a plus b the whole square minus 2ab. See, when we have a square minus b square, when we have an expression that's of the form a square minus b square, a square minus b square, then we factorize it as a plus b into a minus b. But what if you have an expression that's of the form a square plus b square? That cannot be factorized further. See, this is not factorization is writing an expression as a product of its factors. When you can write an expression as a product of its factors, so something into something, one factor into the other factor into the other factor. So a square minus an expression that's of the form a square minus b square can be expressed as a product of its factors a plus b into a minus b. So these are the factors. A plus b is one factor, a minus b is the other factor. The product of the factors a plus b into a minus b, product of the two factors, is the expression a square minus b square. But a square plus b square, you cannot factorize further. You can just write it in a different way. See, these are not the factors of this expression, because you can clearly see that this one, this side is not a product. It's a plus b the whole square minus 2ab. It's not a product. Only if you write an expression as a product of two or more terms. When you write an expression as a product of two or more terms or two or more expressions, it's factorization. Okay, see, now what is a cube minus b cube? It is a minus b into a square plus ab plus b square. So this is factorizing. We've factorized if an expression is of the form a cubed minus b cubed, you can factorize this expression. The two factors are a minus b and a square plus ab plus b square. These are the two factors of the expression a cube minus b cube. And you can see that the given expression a cube minus b cube, here it's the identity. I'm just saying, so if the expression of if the given expression is of the form a cubed minus b cubed, it can be factorized as a minus b into a square plus ab plus b square. These are the two factors of a cubed minus b cubed. Okay. So a squared minus b squared can be written as a plus b into a minus b. But what about a squared plus b squared? So if you find that in trigonometry, a square, if something of the form a squared plus b squared, write it as a plus b the whole square minus 2ab. A plus b the whole square minus 2ab. So it's a derivative of this identity. It's from this identity. Using this identity, we get this a square plus b square from this identity. All right. Okay. So a plus b the whole cube is equal to a cubed plus b cubed plus 3ab into a plus b. Just write it the other way. Just write this the other way. A cubed plus b cubed plus 3ab into a plus b is equal to a plus b the whole cubed. So now on transposing this term, on transposing this, we get a cubed plus b cubed is equal to a plus b the whole cubed. This is one term. This is one term. So the term is 3ab into a plus b. That's the term. 3ab into a plus b is a term. It's preceded by a plus sign. So when it's transposed, minus. A plus b remains a plus b because this is one term. Okay, so a plus b the whole cubed is a cubed plus b cubed plus 3ab into a plus b. Just write this identity the other way around and transpose this term 3ab into a plus b. So that way you will be able to get an expression for a cubed plus b cubed. What is a cubed plus b cubed? A plus b the whole cubed minus 3ab into a plus b. Similarly, and we also know that this is all of 9th standard, but we have to recall because I can't assume that all of you remember this. So should I tell you how to? Okay, all right. So proceeding with this, okay. So proceeding with this one, what is a cube plus b cube? Now take out common. When you take what is common? A plus b the whole cubed and this term what's common? A plus b is common, right? A plus b is common, right? Actually, I don't have to tell you this step, but a plus b is common. So what do you have here? A plus b the whole square, right? Minus 3ab, correct? Okay, so working with this, we get the other identity. A plus b, when you expand this, a square plus b square plus 2ab minus 3ab. So on simplifying the second bracket, we get a square minus ab plus b square. So you can just remember this one. A cube plus b cube is equal to. Remember this one and this one. So a cube plus b cube is equal to a plus b the whole cubed minus 3ab into a plus b is one way of writing. A cube plus b cube is also a plus b into a square minus ab plus b square. So you have to remember, you understand these are the steps involved in getting this one. Remember this one, what I've ticked here. Okay, a cube plus b cube is equal to a plus b the whole cube minus 3ab into a plus b. Remember this. And the last one, a cube plus b cube can also be written as a plus b into a square minus ab plus b square. Remember these two. The other steps are like how we get them. And this is the identity from which we get these. This is the identity. A plus b the whole cube is equal to, this is the identity from which we get these. All right. Okay. Then okay, then we have a minus b the whole cubed. What's a minus b the whole cubed? A cubed minus b cubed minus 3ab into a minus b. A cubed minus b cubed minus 3ab into a minus b. See, now you'll be wondering, how did we get all this? See, when you multiply a minus b into a minus b into a minus, when you multiply this is what you will get. So you should multiply these two. That result should be multiplied with this. When you do that multiplication, so this multiplication we've learned in 8th standard. So when you do find that product, this is what you will get. You will get minus 3a square b plus 3ab square. Minus 3a square b plus 3ab square you will get. When you take out common, this is how it look like. So now writing this identity the other way, writing it the other way, the same identity. When you write it as a cube minus b cube minus 3ab into a minus b is equal to a minus b the whole cube. Okay, so and now when you transpose this term, we have a cubed minus b cubed is equal to a minus b the whole cube. Plus this is one term. This is one term. It will come as it is on the other side. Here it will come as it is on the other side. 3ab into a minus b. 3ab into a minus b. Minus becomes plus. Okay. Now working ahead with this, a minus b is common, right? So this is one expression. This is the other expression connected by a plus sign. A minus b the whole cubed. Here we have a minus b. So a minus b is common. See, like when you have x cubed plus, for example, 3x. X cubed plus 3x. What's common? X is common. So in the bracket x squared plus 3. Right? In the same way here, a minus b the whole cubed is common. So in the bracket, a minus b into what is a minus b the whole cubed? A minus b the whole square. A minus b into a minus b the whole square is a minus b the whole cube. Then the second term, we have the a minus b outside. So what should you write here? Into 3ab and close it. Now simplify. You have a minus b. When you expand this, plus b square minus 2ab and plus 3ab. So a cubed minus b cubed is equal to a minus b into a square plus ab. When you simplify minus 2ab plus 3ab, you'll get plus ab plus b square. Right? Then so after this, we have a to the power 4 plus b to the power 4 and a to the power 4 minus b to the power 4. Okay, so we do these two. Let me do a to the power 4 plus okay, minus first. Anything first. So you can write this as a square the whole square minus b square the whole square. Correct? A square the whole square minus b square the whole square. So now it's a difference of two squares. So it will be a square plus b square into a square minus b square. Because it's like x square minus y square, x plus y into x minus y. So a square plus b square into a square minus b square. Now this a square minus a square plus b square, we just learned something, no? So it is what? A plus b the whole square minus 2ab. We just saw that. And a square minus b square, we already know is a plus b into a minus b. So now this is of the form x squared plus y squared. This one. This one. Okay, like squares connected by a plus sign, sum of two squares. So whenever it is a sum of two squares, a square plus b square, sum of two squares, a square is a square, b square is another square, plus, so a sum of two squares, a square, b square, sum of two square, a square plus b square, should be written as a plus b the whole square minus 2ab. So here we have a sum of two squares. So this is one term. This is squared. This is the other term. This is squared. A square is the term squared plus b square squared. See, this is a. This is your a square plus this is b square. What is a square plus b square? A plus b the whole square minus 2ab. This is your a. See, this is a square. This is b square. So a square plus b square is a plus b the whole square minus 2ab. See what? Square. So what you write inside? See this one. This is your a square plus this is your b square. So this is a plus b the whole square. This is your a plus this is your b whole square minus 2a square b square. Now what is this a square plus b square? What is a square plus b square? A plus b the whole square minus 2ab minus 2a square b square. So if needed, very rarely used, but if at all, very rarely used, but if at all you come across a situation like this, this is how we'll have to proceed. All right. Okay. Make a note of all this. You can change the order and write it if you want. Like if you want to write this one and then below that, if you want to write this, you write it. If you write the first one and from the first one we've got this, no. If you want to write it below that, write it however you want. Yeah. Make a note of it neatly. Very important identities. Online children, please write down. Finished? Finished? Done writing, online students?
Completed, ma'am.
Okay.
Completed.
Yeah, good.
Completed,
Yeah.
ma'am.
Yeah, very good. Yeah, this is the next slide. Slide down fast. Yeah. Finished? Done, all of you? Online children, finish this one?
No, ma'am. 2 minutes.
Yeah. Done?
Yes, ma'am.
Okay. Yeah, this is the next slide. No. Yeah, this is the next one. Finished? Yeah. Done writing, online children?
Yes.
Yes, ma'am.
Okay. Finished here, all of you? Okay. So see this one. Prove that sine A to the power 4 plus cos A to the power 4. Yeah, that's what we have. Is equal to whatever you see in the RHS. All right. Okay. So now tell me. The RHS you can see is made up of sine and cos. The RHS is 1 minus 2 sine square A cos square A. So how shall we do this? I've written the LHS. So can we write it as sine square A the whole square plus cos square A the whole square? Can we write it like this? All right. So because it's already in sine and cos, what can we do? It's already in sine and cos. So let's write the power 4 as 2 into 2. Sine square A the whole square plus cos square A the whole square. Now this is of the identity A square plus B square. The identity is A square plus B square. So this can be written as A plus B the whole square minus 2AB. So using this identity, what is your A here? What's your A here? Sine square A. And what's your B? Cos square A. Cos square A. Okay, so you can proceed like this. A square plus B square is A. This is your A plus this is your B, the whole square minus 2AB. Minus 2AB. In the identity, in place of A and B, we're using sine square A and cos square A. So now in the bracket, what do you have? Sine square A plus cos square A. What is that? 1. And 1 the whole square. All right. Minus 2 sine square A cos square A. So 1 the whole square is 1 minus 2 sine square A cos square A, which is the RHS. Right now. Finished? Good. Done, children? Online?
No, ma'am. 160.
Okay. Yeah, time up. All right, I'm sorry. Take a screenshot if you've still not finished, children.
Completed.
Yeah. Okay. So we need to show that sine to the power 4, sine a to the power 4 minus cos a to the power 4 is equal to sine square a minus cos square a is also equal to 2 sine square a minus 1 is also equal to 1 minus 2 cos square a. Okay, you'll have to take a sine a to the power 4 minus cos a to the power 4 and show that this can be written in these three different ways. All right. Okay. So it's of the form a square minus b square, right? So what is a square minus b square? A plus b into a minus b. So a, this is, oh, sorry. Yeah. All right. Sine square a is nothing but sine a the whole square. Sine a into sine a. Sine a into sine a is sine a the whole square, which is sine square a, which is written like this, sine square a. Okay, so a square minus b square is a. What is a? Okay, let me write that. So this is of the form a square minus b square, which can be written as a plus b into a minus b, where a is sine square a and b is cos square a. So now here in this identity, where we have a and b, you need to write sine square a and cos square a. So is equal to, we are continuing here, equal to sine square a plus cos square a plus b into a minus b. Minus b. Uh-oh. All right. Now, sine square a plus cos square a is 1. So 1 into sine square a minus cos square a, which is nothing but sine square a minus cos square a. So I think we proved the first part. So we need to continue with this. You need to continue with this. Okay, so in the second one, we have only sine. It's 2 sine square a minus 1. That means cos is absent. So you need to replace. See, you're continuing with this one. When you look at the next expression, we have only sine. We don't have cos there. So how do you replace cos square a? Cos square a is 1 minus sine square a. Yeah, so continue. Sine square a minus cos square a is 1 minus sine square a. 1 minus sine square a. See, minus. Cos square a is 1 minus sine square a. And there's a minus, no? So we should write it in a bracket. So sine square a minus 1, minus into minus plus sine square a. So sine square a plus sine square is 2 sine square a. 2 sine square a. Like a square plus a square is 2a square. A square plus a square is 2a square. So 2 sine square a minus 1. So you can see that next one. And then you see only cos. You can continue with this one, or you can take this and over. You can do anything. You can continue with this. You can continue with this one, or you can go back to this. You can take this and work. Anything is fine. Anything is fine. So if you want to continue with this, what is sine square a? 1 minus cos square a. Sine square a is 1 minus cos square a. I said you can also take up this again and do it like this. Okay, so we are continuing. So 2 into 1 minus cos square a minus 1. So this is 2 minus 2 cos square a minus 1, because 2 into 1, 2, minus 2 cos square a minus 1. So it is 2 minus 1 is 1. 2 minus 1, 1. 1 minus 2 cos square a. All right. Yeah, please take down. Finished? Finished writing? Online children?
Yes, ma'am.
Okay.
Ma'am.
Done here, all of you? Okay. So now when we have 6, you can write it as 2 into 3 or 3 into 2. Okay, now sine theta to the power 6 or sine A to the power 6, whatever. We have 2 options. Okay, we have 2 options, but only one you can go ahead with. So let's understand why and which one. So it can be written as sine cube theta the whole square. A to the power 6 can be written as a square the whole cubed or a cubed the whole square. When the base is raised to many powers, what should you do? Multiply the powers. When the base is raised to many powers, multiply all the powers. So a is raised to 2, the whole power 3. So multiply the powers. 2 3s are 6. So you can write it as a square the whole cubed or a cubed the whole square. Both are fine. But when we have sine theta to the power 6, we choose not write sine cube theta because identities are all like this, right? So we choose to write sine square theta, the whole cubed. We don't want to write sine cube theta, the whole square, because sine, we don't have an identity. All identities are in power 2, right? So we prefer to write sine square theta than sine cube theta. Am I clear? Yeah. So the left hand side, sine A to the power 6 plus cos A to the power 6. Okay. So we will write it as sine square A the whole cubed plus cos square A the whole cubed. We'll not put the 3 inside. We'll put the 3 outside. We'll write as sine square A because identities have power 2, right? Trigonometric identities. So sine square A the whole cube plus cos square A the whole cube. Now this is of the form A cubed plus B cubed. Now you know 2 things for A cube plus B cube. You can use anything. So we'll do it both the ways. So A cube plus B cube we know is A plus B the whole cubed minus 3AB into A plus B. Okay, the other one we'll do it later. So now wherein A is sine square A and B cos square A, right? Okay, correct. So A plus B the whole cubed. This is A plus this is B the whole cubed minus 3A. And we're just substituting. We have the answer here. Nothing we're doing. See, we have the answer here. Here in this answer, where we have A, we're using sine square A, and where we have B, we're using cos square A. That's all. So 3 sine square A cos square A into, this is 3AB into A plus B into, this is A plus, this is B. Now, sine square A plus cos square A is 1 cubed. 1 தானே எழுதாம இருக்க கூடாது 1 எழுதணும் 1 minus don't ignore 1 it's 1 so don't not like that see if it is 1 by 1 this is different from 1 plus 1 children okay 1 by 1 okay is 1 only but 1 plus 1 is going to be 2 yeah so don't ignore writing 1 here you'll have to write 1 the whole cube minus 3 sine square A cos square A into 1 right? So this is 1 minus 3 sine square A cos square A, which is the RHS. Right on. We'll do the other way also. Other way meaning using the other identity. First write this. Yeah. Finish writing, online students?
Yes, ma'am.
Yes, ma'am.
Okay. Done here, all of you? Okay. Using the other identity. So the identity is a cube plus b cube is equal to a plus b into a square minus ab plus b square. I think two steps extra varlam. We'll see. So okay, what is a here? What is a here? Sine square a and b cos square a. So substitute using the identity a plus b. So sine square a plus cos square a into a square. Okay, so it will be sine. This is a square. Okay, minus ab minus this is a into this is b plus b square. This is b and this is b square. So here it's 1 into and let me not we'll again have to put it in that form. So sine square, I'll just gather it and write it next to it. So this is a square plus b square minus sine square a cos square a. Now this again a square plus b square. What is a square plus b square? No, I didn't write it as sine a to the power 4 because again we have to write it as sine square a the whole square only. When you see if you write it as sine a to the power 4 and then cos a to the power 4, anyways you cannot stop there. You'll have to write that 4 again as 2 into 2 and proceed using a suitable identity. So I've not done 2 into 2 4. I've just gathered it sine square a the whole square and cos square a the whole square. I've just written it one next to one another and minus this one sine square a cos square a. Okay, so here we have just gathered the two terms. 1 into, no, don't write the 1. Don't have to write the 1. So what do you get? What is a square plus b square? A plus b the whole square. A square plus b square is, this is a plus b the whole square. A plus b the whole square minus 2ab minus 2. This is a, this is b. And we already have one minus sine square a cos square a, write that. Now in the bracket, sine square a plus cos square a is 1 and 1 square is 1. Minus, they're like terms here. Sine square a cos square a, sine square a cos square a. They're like terms. Like minus 2a square b square and minus a square b square is minus 3a square b square. So like that here, that's what we have here. So minus 3 sine square a cos square a, which is the RHS. So slightly lengthy. So don't use this. You should know how to do it, but you should not use this because you'll spend time doing this. So you should use this identity. This will help you finish faster. Yeah, but please, You can practice this one also. So it's left to you. But write down now. All of you please write down now. Alternate method. Tell me when the clock strikes 9, okay? I think you're prepared for the test on statistics. Yeah. Finished writing, Prenu? Yeah. Okay, finish, children. If you hear, ask if you're drawing or writing. Finish writing, yeah. Online children, finish writing.
Yes, mom.
Good. So what's the rule? Whenever there's something common, whenever there's something common, take out the common factor, no? That's a rule, right? When you have a to the power 4 minus a square. So a square is common. So a square minus 1. Just applying algebra here to trigonometry. Simply applying algebra to trigonometry. If you have a to the power 4 minus a square, how will you factorize this expression? Or how will you proceed? So since there's something common, take out the common factor. Same thing here. Cos square a is common. So cos square a minus 1 in the bracket. Now look at the RHS. RHS has no cos. It has only sine. So what is cos square a? 1 minus sine square a. Because why are we doing this? Because look at the RHS. It's only sine RHS. And by taking out common, the power 4, see, we don't want power 4 because we don't know what to do with power 4. We want only power 2 because with power 2, you can write it using an identity. You can write it in a different way. If the power is 4, we don't know what to do. That's why we took out cos square a common. So when you take out cos square A common, you can see now it's cos square A minus 1. So this is the relief, no? So power is 2. Now we can do something. But when the power is 4, yeah, so you take out cos square A common. Now cos square A is 1 minus sin square A. And what is cos square A minus 1? What is cos square A minus 1?
Sin square.
No. Write down all of you see. Somebody gave the answer, but you're not sure. Loudly. Huh? Minus sin square A. See, sin square A plus cos square A is 1. What is cos square A minus 1? So this one is here only, cos square A minus 1. So this is coming here, minus 1. Yes, this will go here, minus sin square A. Yes or no? Cos square A minus 1 is minus sin square A, not sin square A. Sin square A plus cos square A is equal to 1. So cos square A minus 1 means you should transpose the 1, no? So cos square A, and this 1 comes to the left-hand side, so minus 1. So you must push sin square A to the other side, so it will become minus sin square A. So cos square A minus 1 is minus sin square A. Minus sin square A. Now multiply. Multiply, open the brackets. So minus sin square A into 1. You'll have to multiply. Minus sin square A into 1. Minus sin square A. Then minus sin square A into minus sin square A. Minus into minus plus. Sin square A into sin square A is sin A to the power 4. Now, just write it in this order. Which is the RHS. Write down. Finished? So first we take out common. Then we look at the RHS, it's only sine. So cos square A is 1 minus sin square A. Cos square A minus 1 is minus sin square A. After this, you just have to multiply. And we get the RHS. Okay. Next one. So again, everywhere, see, we're using identities. Okay, so should be very sure about the identities. That's the backbone. Now this is of the form a square minus b square. Okay, so you need to factorize as a plus b into a minus b. So this is cot square a the whole square minus 1 the whole square. So this is of the form a square minus b square, which should be written as a plus b into a minus b, where a is cot square a and b is 1. So a plus b, this is a plus this is b, and this is a minus b. Now look at the RHS, it's cosecant. It's very easy, when we have cot and we'll have to change it to cosecant, it's very easy because they're connected using the identity. Cosecant square A minus cot square A is 1. So switching between cot and cosecant is easy because they're connected. In the identity, cosecant square A minus cot square A is 1. So first, when you look at it, it's of the form a square minus b squared. So a plus b into a minus b. Now what is cot square A plus 1? Okay, let me write the identity here. So cosecant square A minus cot square A is equal to 1. So what can we replace? What is cot square A plus 1 using the identity? Why? Cot square A plus 1. Transpose. Cosecant square A is equal to 1 plus cot square A, which is also cot square A plus 1. It's cosecant square A, right? No, you can ask me if you have a doubt. 1 second. What's your doubt? See here. No, you don't have a doubt actually. I'll tell you. Cosecant square A minus cot square A is equal to 1. We need to check if we can get for cot square A plus 1. This is already plus 1. Okay. So when you take this minus cot square A to the other side, it will be cosecant square A is equal to, now this minus when it comes here, it will be plus no, so cot square A plus 1. So cot square A plus 1 is cosecant square A. Cot square A minus 1. Look at the RHS, it's all cosecant only. So you have to change. Cot square A minus 1. Okay, so what you can do here is you can write, see, you're not able to substitute for cot square A minus 1 directly using the identity. In that case, what you do, right? What is cot square A? What is cot square A? Cosecant square A minus 1. Substitute that, that's all. See, in the first bracket, we have cot square A plus 1, which can be written as cosecant square A using the identity. Now, the second one looks a little difficult. Cot square A minus 1, we are not getting it using the identity. No, cot square A minus 1, we are not getting, right? So no worries. You're not able to substitute, right, using the identity. Don't do that. What is cot square A? What is cot square A? From this identity, what is cot square A? Cosecant square A minus 1 is cot square A, right? Cosecant square A minus 1 is cot square A. So instead of cot square A, right, cosecant square A minus 1, and that minus 1 as it is. So it becomes cosecant square A into cosecant square A minus 2. Now multiply. Open the bracket. So it will be cosecant A to the power 4 because A square into A square is A to the power 4 minus 2 cosecant square A, which is the RHS. All right. Okay, right now. Have you carried your statistics classwork for the statistics test? Yeah, very good. No? Okay. Huh? You have another book. Okay. Done, children?
Yes, ma'am.
Yeah. So tell me what's the rule here? What should be the first move? The first step? So whenever there's something common, take out the common factor. Okay. So sine square A, sorry, secant square A is common. Okay. So secant, and again, look at the LHS is made up of secant A and the RHS tan A. So you can easily switch from secant to tan. Secant square A minus tan square A is 1. So using this identity, you can, switch from secant to tan, tan to secant. Okay, so first we'll take out secant square A common. So in the bracket, you get secant square A minus 1. Now, what's the identity? Secant square A minus tan square A is equal to 1. Okay, so what should you write for secant square A? Secant square A is 1 plus tan square A or tan square A plus 1. See, because we'll now after taking out common, now we'll have to change secant to tan because RHS is all in tan. So secant square A from the identity secant square A is you can write 1 plus tan square A or tan square A plus 1. Both are correct. 1 plus tan square A. And what is secant square A minus 1? Transpose. What is secant square A minus 1? Secant square A, this one comes here. Minus 1 is equal to, so this will go here. So is equal to tan square A. Secant square A minus 1. 1 plus 1 comes here as minus 1. So secant square A minus 1 is equal to minus tan square A goes to the other side. Plus tan square A. So secant square A minus 1 is tan square A. It's just tan square A here. Now multiply. See, that's what you do, no? Like if you have 1 plus a square into a square, what do? You will multiply, right? 1 into a square plus a square into a square, a to the power 4. Same thing here, multiply this and this, tan square A. Okay, so you get tan square A and multiply this with this plus tan A to the power 4. Just write it in the order it's given the question. So tan to the power 4 A plus tan square A, which is the RHS. Yeah, right on, children? Finish writing? Yeah. Online children, finish writing?
Yes, ma'am.
Yeah.
Yes.
Yeah, good. Yeah, so now having done all this, you can help yourself with this one. Yeah, please understand and do this. So I've just worked it in a few steps. I'll tell you what I have done. Tell you what I've done. So you can see here, prove the trigonometric identity. This one is equal to 0. All right. This one is equal to 0. So I have just taken up, I've done it in parts. I've worked this one. Then I have worked this one. And then, like put everything together. Okay. Yeah. Yeah, do this. Just write from the board, and as you write, understand what you're writing. I think because he's also new. Okay, no problem. No, we'll do it because I don't know if it's his first class. I don't know if he can do it. We'll do it together. See here. So 2 into sine theta to the power 6 plus cos theta to the power 6. We'll just take up this one first. Okay. So tell me, is in the form? Correct? Yeah. So this is not the LHS completely. I'll just say step 1 here because it's not the LHS completely. I'll just call this step 1. Okay. Yeah. A cube plus B cube. A cube plus B cube is? A cube plus B cube is A plus B the whole cubed. A plus B the whole cubed minus 3AB into A plus B. All right. 2 outside. See, the square bracket starts here and ends here. Inside that we have A cube plus B cube is equal to A plus B the whole cubed minus 3AB into A plus B. For all this 2 is multiplied. By mistake, if you don't put this bracket and put the 2 like this, no, I'm saying if you just do this, you're wrong. You put the 2 here like this. You're wrong because then you're multiplying 2 only with this one. What about the rest of it? So the bracket is very important. So this entire thing is multiplied by 2. So from here to here, everything is multiplied by 2. Okay, so now 2 into this one is 1 minus 3. Okay, let me write 1 cubed. Okay, 1 the whole cubed minus 3 sine square theta cos square theta into 1. So it is 2 into 1 minus 3 sine square theta cos square theta, which is now multiply 2 into 1, 2 minus 6 sine square theta cos square theta. Yeah, right on this. Then we'll do the second one. Yeah. Quickly write down. A cube plus B cube is A plus B the whole cube minus 3AB into A plus B. Okay. Now the second part. We'll take the minus sign later. We'll just take 3 into, we'll take only this 3 into. We'll take the minus sign later when we put everything together. So 3 into step 2. We'll call this step 2. Step 2. What is that? 3 into. Okay. So 3 into sine theta to the power 4 plus cos theta to the power 4. All right. Yeah. So 3 sine square theta the whole square plus cos square theta the whole square. 3 a square plus b square is a plus b the whole square. A plus b the whole square minus 2ab. 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 A plus b the whole square minus 2ab. 3 into, see, bracket square bracket. 3 into 1 square minus 2 sine square theta cos square theta. So this is nothing but 3 into 1 minus 2 sine square theta cos square theta. Open the bracket. Open the bracket. So you'll have 3 minus 6 sine square theta cos square theta. Now we'll put everything together. In step 3, we'll have the LHS. Step 3 is the LHS. Now the LHS. LHS is equal to, we'll have to write this answer. Correct? 2 minus this one. You can write the LHS also if you want. Just read it for me. 2 into sine theta to the power 6 plus cos theta to the power 6. Then minus 3 into sine theta to the power 4 plus cos theta to the power 4 plus 1. Okay. This is the LHS. So now we'll write the answers we've got. 2 into this is 2 minus 6. 2 minus 6 sine square theta cos square theta, correct? Okay, this one in one bracket minus sign நம்ம முன்னாடி எடுக்கல, so minus போடணும். இதோட ஆன்சர் என்ன வந்திருக்கு இங்க? இதோட ஆன்சர் 3 minus 6. 3 minus 6 sin square theta cos square theta. அப்புறம் அது plus 1. Okay, so 2 minus 6 sin square theta cos square theta minus 3 plus 6 sin square theta cos square theta plus 1. And the plus 1 was not multiplied with anything. Plus 1 is away from the brackets. So what happens now? Cancels. Then minus 3 plus 2 is minus 1 plus 1, 0, which is the RHS. All right. Write down. Yeah, this is the next slide. This is the next slide. I know. Done, children? Finish writing? Okay. Yeah. Yeah. Quickly write down. All this will be easy for you to understand. Just write down with me. I think I explained this in the last class also. So what is that which we have added? What is extra here? Sin square theta plus cos square theta. What's the value of that? 1. Yeah, so you can do it. A cube plus B cube. We have A cube plus B cube plus 3AB, but we don't have A plus B. So you just complete that A plus B, but you're not changing the value of the expression because it's just 1. The value is anyways 1. See, if the expression we have is of this form. So this is the answer. The expression here is of this form. A cube plus B cube plus 3AB into A plus B. So you write it as A plus B the whole cube. That's what you've written here. A plus B the whole cube, which is sine square theta plus cos square theta the whole cube. All right? Jayavashni? Understood? All right. Finish writing, no, all of you?
No, ma'am.
Oh. Yeah, finish it and let me know.
Yes.
Okay. Okay. So first we write it as a difference of two squares. First we like, see, whenever there's a minus, you know, we'll write it as a difference of two squares so that you can factorize using the identity a square minus b square is equal to a plus b into a minus b. Whenever you can write it as a difference of two squares, choose that. Now 8 can be written as 4 into 2, right? Put the 2 outside. Put the 2 outside because then it will look like a difference of two squares. So write it as sine theta to the power 4 the whole square minus cos theta to the power 4 the whole square. Write it like this first. So now this is a squared minus b squared is a plus b. This is a plus b into this is a minus b. Correct? Now this one should be written as, now either we've done it earlier, no, same steps you'll get. Sine theta to the power 4 plus cos theta to the power 4, we've done it earlier, no, same steps you'll get. Here, what is this one? Sine square theta the whole square minus cos square theta the whole square. So see here, next step, you need to write it as sine square theta the whole square plus cos square theta the whole square. And here, sine square theta the whole square minus cos square theta the whole square. Now this is a square plus b square. A square plus b square is a plus b the whole square minus 2ab. 2ab, correct? A square plus b square is a plus b the whole square minus 2ab. The next bracket is a square minus b square is a plus b into a minus b. Then here, what do you get? Sine square theta plus cos square theta is 1. 1 square minus 2 sine square theta cos square theta. Here again sine square theta plus cos square theta is 1 into sine square theta minus cos square theta. So now you can use a simple bracket 1 minus 2 sine square theta cos square theta into sine square theta minus cos square theta. That's it. We got the RHS. Just write it the other way. Sine square theta. We got it already. Just writing it in the order we see in the question, which is the RHS. Yeah, write down. Yeah, those who've got your statistics book, open that, finish this and open that book. Those who have not got the book, if you have a different book, you can work it on that, or you can collect the sheets from here. You can just pick a few sheets from here. Finish writing, all of you? Done? Yeah. Online children, finish writing?
Yes, ma'am.
No,
Very good.
no, ma'am. Last line, ma'am.
Okay. The best way to learn is by teaching yourself. You should teach yourself all these identities. You should always remember. It shouldn't be like 1 minute, let me just revise. No. Like how we remember A to Z, do we forget? No, no. There are so many things which are very basic now for us. So we don't revise them, no, we always remember them. In the same way, the algebraic identities which we saw today at the beginning of the session, you should always know that. For that, you should practice. For that, you should practice. Practice and it should become like ABCD for you. You should always know that without any confusion. You must be sure about the identities. In that case, all this will look very easy. These identities will look easy for you. If the, meaning the proving these trigonometric identities. If you have trouble not trouble. If you have not practiced, then you will have trouble remembering the identities. Then all this will look difficult for you. You can see we have taken help of algebraic identities to prove all these trigonometric identities. Yes or no? And when we use an identity, one part of the identity is the question, the other part tells you the answer. So you're just substituting there. You're not doing anything by yourself. When you're using an identity to work, your work is still easy because in the identity, one side you have the question, the other side you have the answer. Correct? So you're only substituting. You're using the identity, and for A, you're substituting something, for B, you're substituting something. Yeah. Okay. So now, online children, get your statistics notebook, and all of you here also, write down, just give the heading, revision test 1. You have not gone through, I didn't share statistics videos with you, no? Then you've watched? Yeah. Yeah, online children and children here, open your statistics book, revision test 1, write down the identities. Oh, write the identities. Sorry, write the formulae. Huh? Write the formulae. So the first one is the formula to find mean using the direct method and the assume mean method. Then write the formula to find median, and then the formula to find mode. Write on. Online children, write. On the back and refer No, what? Yeah, what the letters stand for, like n by 2 is this other line. This is a formula. You might have to explain the variables used in the formula. Yeah, right. How do you answer all of them? Yeah. Won't help your friends. right into the point. 0 is strong. I one formula எல்லாருமே எஃபெக்ட் கொடுத்தீங்க இல்ல நான் கை கொடுத்தேன் ஆமா நீங்க என்னன்னா minus my it's one only it's one because I saw one you know step one and step incomplete loss. L plus infinity. It's a very important like unfortunately information about the market. Then yes, it might be. You have to be clear. Yes, it might be A plus. Medium format plus n maybe minus plus minus 3 by more. Something is mistake. The best of 1 minus not by the 1 minus the minus not be much. Two is not really. How 1, 2, wrong, correct. Formula correcta தெரியாதவங்களா? Please learn, write and learn the formula. Without that, if your formula தெரியலனா what should I don't have to explain on that. You know, if you don't know the formula, then how will you work the answer correctly? Okay. So those of you who have yeah, this is the test question. Please copy the question and then work the answer. So what are the columns we need to have for median? Kalyan, no, what's your name? Keshav. Yes, Keshav. Yes. Don't get up, sit down, sit down. You need to have, what are the name, all the columns? Columns தான் கேக்குறேன். Columns என்னென்ன வேணும்? Class interval column வேணும். அப்புறம் next frequency column, cumulative frequency column, அப்புறம் heightன்றது ஒரு வேல்யூ தானே. அதுக்கு ஒரு column போட மாட்டோமே. என்னென்ன columns வேணும்னு கேக்குறேன். CI போடணும், அப்புறம் frequency, அப்புறம் cumulative frequency, அப்புறம் வேற ஏதாவது column வேணுமா? அவ்வளவுதான். Okay. Should the class intervals be made continuous, or it's okay if they're not continuous? They should be continuous. In this question, are the class intervals continuous? They are continuous. If they were not continuous, you must make them continuous, correct? You must make them continuous. In the case of median and mode, you should make them continuous. Okay. Next, Prenu, identify the median class interval. Which is the median class interval? Fast, loud and fast. Sadhana, loudly. 3,500? No. Asif, sit down, don't get up. வீட்டுக்கு அனுப்ப மாட்டேன்னா இங்கே லாக் பண்ணிட்டு போயிடுவேன். Why? No, you're right, but why? Online children, identify the median class interval. Anybody can answer, open question. Anyone answer online? Yeah, quick. Raise your hand, online children. Online children use the emoji. Raise your hand. Okay, good. Median class interval.
Mom,
Yeah, tell me.
Mom, is it 5,000?
Class interval in Kekane 5,000. You're giving me one number. I'm asking you the median class interval.
4,500 to 5,500.
Correct. Because the value of median is 5,000. You're right. You were right. The value of the median is 5,000 and it lies, that value 5,000 lies in the class interval 4,500 to 5,500. So that's the median class interval. Yeah, complete this. Five plus six and 5 plus x plus y, 5x plus 9 and 17. B x minus a1, B not B. This one. Minus C and then so next we will do minus we want to do minus C. So minus of course you will do or number that you have so that you back end. Frequencies of the glass. See the median frequency. You are having a sleeve of the median frequency. The sum will set up coming 3 times work on it. Since it's time, I'm showing the answer. So I'm happy with Jai Varshini, Bhavishya, Swati, Sa. Renu not able to do, right? Completed now. Okay, and Renu. Somewhat this guy. The others need to take effort. Please take the effort needed to remember whatever you don't know today. That's all it is. So next time you can do well. So please check your steps. Online children. So let me quickly take you through the answer. See here. Class intervals as it is. Class intervals as it is. Okay. Frequency column as it is. The total is given. See, 60 top batsmen. So 60. The total of the frequency column is 60. Right? And then the cumulative frequency column. So I saw somebody writing 5x. It's 5 plus x. Then 5 plus x plus y. 5 plus x plus y. It's not like that. You need to write everything carefully. Only then you will get the correct answer. Write carefully. So all of you please check. Do it along with me. Don't go in your own pace. We'll do it with me. So have you written? Did you realize that the total of the frequency column is 60? You should n by tokening on the 25 plus x by n by tokening on the 25 plus x plus y by 2 போட்டிருக்கீங்களா? அப்படின்னா நீங்க எலாபரேட்டா பண்ணிருப்பீங்க அவ்வளவுதான். நீங்க 60 by 2 13 போட்டிருக்கணும். யார் போட்டிருக்கீங்க? 60 by 2 30. Total of the frequency column is known 60. So n is 60. N by 2 is 60 by 2 30. But if you take 25 plus x plus y, that is n, no? The total of the frequency column is also this. N by 2, if you have taken 25 plus x plus y by 2, that's also correct. You will get the answer. But unnecessarily, you're, like complicating the work. Okay. So check all this. So this is the total of the frequency column. Please check your cumulative frequencies. The last one is 25 plus x plus y. And then you should equate these two. 25 plus x plus y is equal to 60. So you get x plus y is equal to 35. This is one equation. Then median is given 5,000. The median class interval is this one. And then write the other, parameters. N by 2, 60 by 2, 30. L is the lower limit, 4,500. Cumulative frequency is of the class preceding the median class interval. Okay, so this one before the median class interval. And frequencies of the median class interval. Frequencies of the median class interval. Y. And H is the width of the median class interval. Width of the median class interval, 1000. இதெல்லாம் எழுதணும். இப்ப median is given to be 5,000, no? Median is 5,000. Abdina, L plus n by 2 minus CF by F into H is equal to 5,000. This is 5,000. This is median. This one is 5,000. Now substitute the values. So Bhavishya, see, you just wrote minus 5 plus x like this. After the minus sign, you're writing an expression. So you should put it in a bracket. After the minus sign, CF is what? 5 plus x. It's an expression. If it's a plus here, no problem. Ninga bracket podlenalum paravalla. Minus. So put it in a bracket, 5 plus x. So next step, it will become minus 5 minus x in the next step. Okay, so first thing either transpose panno this one. 4,500 will go to the other side. So 5,000 minus 4,500. So this will give you 500. Then this into 1,000 will come as by 1,000 to the other side. See, but I saw எல்லாருமே complicated. எல்லாரும் இல்ல, I saw ரொம்ப complicated. Did you get the answer? And don't write like இப்படி எழுதக்கூடாது. You write it like this. Because no, you don't write it like this. You don't use the slash at all here. You should write a fraction like this. Don't write fractions like this. So, see, it's so simple. Tell me what is difficult in this. We have the definitions for every variable. We have the definition. Okay. Okay. Now we have identified the variables here. Sorry, the values for the variables here. Now this is the formula which is 5000. Substitute பண்ணிருக்கோம். Here minus அப்புறம் CF எழுதிச்சு careful எழுதணும். அதுக்கப்புறம் 4500 on the other side minus 4500. And so that becomes 500. And this into 1000 will become by 1000. So see, this becomes so simple now. It's just 25 minus x. 25 minus x by y is equal to, see, you should cancel now. Okay, so it will become, this one will become 1 by 2, right? It will become 1 by 2, right? So now cross multiply. 500, this is 2. Now cross multiply. So you'll get y into 1, y is equal to 2 into 25 minus x. 2 into 25 minus x. So y, okay, then you get this equation. Correct? Now you can use a substitution method. If you don't understand the method I've done here, because this you will learn linear equations. We haven't done that. But if you know this method, you can do it. Otherwise, if you don't know this method, I've taught you the substitution method. No, x plus y is 35. So x is equal to 35 minus y. So put that here. 2x means 2 into 35 minus y plus y is equal to 50. Here, from this one, x plus y is equal to 35, you can write x is equal to 35 minus y. Substitute that in the second equation. 2 into, instead of x, you write 35 minus y plus y is equal to 50. When you work this, you'll get the value of y. Once you get the value of y, put it here and get the value of x. So that's a substitution method. What you see here is the elimination method. Writing the equations one below the other. Write the equations one below the other and change the signs. Why should we change the signs? Because it's plus y. When you change the signs, you're subtracting equation 1 minus equation 2. See, when you have two equations, you can add the equations, you can subtract the equations, you can multiply them, you can divide one by the other. You can perform all the 4 operations with 2 equations. See, if you have A is equal to B and C is equal to D, then A plus C is equal to B plus D is true. You can add the 2 equations. A minus C is equal to B minus D is also true. You can subtract. A into C is equal to B into D is also true. You can multiply the 2 equations. A by C is equal to B by D. You can divide you can divide the LHS and the RHS also. We'll see this again in the next class, but that's what it is. When you have 2 equations, you can perform any mathematical operation with the 2 equations. So here we're subtracting equation 1 minus equation 2. We're changing the signs throughout on the second equation. Other than you see here, key. That is, this plus becomes minus and the plus becomes minus, plus becomes minus. Other than key ring. Okay, so plus y minus y will get cancelled. It becomes 0, right? Then x minus 2x is minus x. X minus 2x is minus x. And the 35 minus 50 is minus 15. So minus gets cancelled on both the sides and x is equal to 15. And now we've got the value of x. Substitute the value of x in one of the 2 equations. Now x is 15, no? So put x 15 here, 15. So 15 plus y is equal to 35. So y is equal to 35 minus 15, which is 20. So if we have complicated, has anyone completed and got the values for x and y? No, but actually it was not difficult. It might have looked like that, but not at all difficult if you had transposed correctly at the right stage. You should bring this for subtraction, bring this for division. That's it. Then it becomes very simple. All right, so with this, you have realized each one of you have done maybe a small minor mistake or maybe a blunder you have done. So whatever it is on your part, realize it, correct it. It's not about feeling bad. There's no point feeling bad. It's about finding the solution and applying it and being better next time. So like that, you become better. You be the best version of yourself, right? Yeah. I'll share this on WhatsApp later. All right, online children. So that's it for today's session. Thank you so much. You can leave the call. Thank you, children. Good night.
Thank you, ma'am.
Thank you. Good night.